Hello, can anyone hear me in the chat there? Wait for some people to join. Okay, I'm gonna hope that my microphone is working properly. I think I can see the bar moving this time, so fingers crossed. So for everyone that watching, we're going to be doing circles today. We're going to be looking at some areas, at some circumference questions, look at some exam questions, how they pop up in the exams. Yeah, that's what we'll be doing. We'll start like in a few minutes. Like hopefully some more people will join. But yeah, we'll just wait to see. Oh, hi Riham. Nice to see you again. How are you doing? You're good. Good. I'm very good too. um, yeah, yeah, very good. It's nice to know that there's people there, and nice to know you can hear me. So I think I may have finally got this whole audio thing figured out. Maybe. But yeah, what have you been up to? I've been quite busy this week. I had birthday last week, and oh, I'll try to fit out the audio. I don't know. I will see what happens next week. It may be a bit of a glitch that I figured it out this week, but I mean, 8 hours in, and I figured out how the microphone button works. I think that's pretty good, right? I think that makes me technically savvy now, so I can add that to my list of skills, figuring out how microphones work. So yeah. We'll start some maths in a second. Yeah, we usually start about 5 past, so we'll give it one more minute, see if we get anyone else, and then we'll just begin with circles. But yeah, I think from doing this, I've realized that, I remember when I was in school always having that teacher who was a complete technophobe. And I think from doing this, I've realized that I've become that person. I've become that teacher. But, oh well, you've got to embrace it, I think. Okay, so. Oh yeah, there's like a My Tutor thing there, like about anything that you would want for future sessions, any feedback you have. So yeah, anyone who has the time, please click on that link and let us know at any point. But we'll get started. So let me go onto the whiteboard. Histograms. Yeah, put that into the feedback, Reham. It's good to know. I think someone last week suggested circle theorems as well. So yeah, it's definitely all good to know what topics would people find most useful. But today we're going to be doing areas and circumferences. we're going to start off with like the basics, learning the equations, and then we're going to look at some of the longer exam questions where they don't guide you so much by telling you exactly calculate this, calculate that. So first things first, let me set myself up a little bit, put all of you over here. So we should first of all just say what the equations are for anyone who might not have covered this yet in school. So for the area, we're going to use the letter A here, pi r squared. And for the circumference, we can say 2 pi r. Yeah, good, perfect, Darren. If for circumference also, sometimes you'll see this written as pi times the diameter, because diameter is 2r. So you could either use either of these equations depending on what they give you in your circle. So, okay, that's like where we're going to start with. There's one other thing that we did kind of cover last week, but for anyone who wasn't here, one thing to bear in mind for these as well is if you get given an equation of a circle, I'm not going to go into too much detail, but say if you have something like this, as long as it's in this form, the number this all equals to is the square of the radius. So it's just one thing to bear in mind for some of the questions. So that's where we're going to start from. These are all the equations you'll need to know for what we're doing. And then we're just going to start off with figuring out circles and circumferences before we look at the exam questions. So do put it in the chat if any of you know the answer. It's good to know, like, if people are following along, if you're happy with this, if you're not happy with this. So circle has a radius of 3.5 centimeters. Work out the area of the circle. So area immediately tells us we're going to use the area being pi r squared. They tell us what r is here. So for this one, it's just plugging it into the equation. So 3.5 squared times pi. And for these questions, how you give your answer, either you can give it in terms of significant figures with decimal places and actually just put pi into your calculator, or you can leave pi in the expression, in the answer at the end. And it depends really on how the question's worded for if you have to do it one of these two ways. But I will put both options here. If it doesn't like tell you how they want you to write it, you can do either way. So good, yeah, I can see some answers here, fabulous. So yeah, if you want to leave it in terms of pi, you want to just say 12.25 pi. And that is a completely valid answer for this. So like say if it was a non-calculator paper, probably wouldn't have 3.5 squared because it's not one they'd be so familiar with, but it could be 3 squared where the radius is 3. Leaving pi in there is completely fine, and in some ways it's more accurate because you're not rounding any numbers. Or you could do it to a certain number of significant figures or decimal places, which I can see people here have like done this. So Reham, Finn, I can see you've done it both ways too, which is great. So yeah, that's going to be 38.5. And we should probably put units in here. So whatever we do to the numbers, we do to the units. So we squared the radius. So we're going to square the centimeters squared, centimeters as well. Good. Okay, so that's just like a little intro question. We'll do another few like just to introduce the circumference as well. So a circle has a radius of 10.5 centimeters. Work out the circumference of the circle. So again, put your answers on the side if you've had a go at doing this. But we're going to use our equation over here. So 2 pi r. Hi, Liba. I'm so sorry if I'm pronouncing it wrong, but nice to have you here. So we're just doing some intro questions. So 2 pi r. Again, you can write this one of two ways. Either you can keep pi in your answer or you can round it on your calculator. So If we want to leave the pi in there, we can just times the 2 and the r together. So that will be 2 times 10.5 times pi. And that is going to just be 21 pi. Or you can put it in your calculator and then round it to a certain number of decimal places or significant figures. Which I'm going to double check this because I get on slightly different to Reham, but I am going to double check. So 21 times pi, oops. Oh no, sorry, I do get the same as you, 66.0. I just wrote it down wrong. So yeah, so that's good. And again, we can put our units in here. Circumference this time, we didn't square the r, so this is just a length. So the units of r are not going to change, and it's just going to be centimeters. Good. Okay, so that's how we work those out. So this one here, this circle has a diameter of 20 centimeters. Work out the area of the circle and give your answers in meters squared. So there's a few things to notice here. First of all, they don't give us radius, they give us diameter. So we want to convert that into radius to start with. So the radius is going to be the diameter halved. So 10. And the second thing to notice is the unit change. So with these questions, you want to be really careful at looking for the units, checking that you're always staying in the correct units. Usually when you're doing shapes, it's much easier to convert the units at the very beginning than to leave it until the end. But I can show you both ways so that if you do leave it till the end, you know how to still deal with those changing units. But yeah, it's something that's really important to bear in mind. So first of all, this is 10 centimeters. I want to convert the units straight away so that in the end I end up with meters squared. So that's going to be the same as 0.1 meters, which means when I go for my area equation, which is pi r squared, I'm going to have pi times 0.1 squared, which is actually going to give me 0.0314. So this is where it's like really important to be careful, because if you just square the, yeah, but Reham, that's a really good to like be aware of, because it's a really common mistake. So, and I'll just show you, like, it's fine to correct afterwards. So this is going to be a meter squared. So in questions in general, if they give us mixed units, is it usually easier to convert the larger or shorter units? E.g. if your question has meters and centimeters. That's a really good question. I would say it depends on what you're calculating. In this one, it's not so much that I'm thinking of converting the centimeters to meters being easier than the other way around. Because in a way, it's not that much easier either way. In one situation, I'm dividing by 100, and the other I'm timesing by 100. However, for this one, the reason why it's easier to convert the centimeters first is because once I do that, I don't have to worry about the fact that I'm squaring my units. So it's much easier to convert a length units than area units. But I'll quickly show you. So this is going to be the same, just as Reham calculated, as 314. I'm just going to do it to 3 significant figures, and that will be in centimeters squared. However, now if I want to convert this to meters squared, the reason this is a bit trickier is because of this square sign. So centimeters to meters, I just divide by 100. If I want to go centimeters squared to meters squared, I have to make sure that when I divide by 100 squared. So I do the same thing to my conversion factor as I'm doing to the units. So that's, I hope that answers your question. So that's why it was easier to do it at the beginning, but you can correct it at this point. Just remember to look for the powers. And this will give you your 0.0314. meters squared. So 2 different ways to get there. Just be aware of that. And then this is the final intro question, and then we'll have a look at some of the exam ones. So the equation of circle C is given below. X squared plus y squared equals 64. Calculate the circumference and area of circle C. Give your answer in terms of pi. Notice here, in terms of pi, they're telling us don't round it. Don't put it in your calculator and round it to a certain number of decimal places. Instead, leave pi in your answer. So first of all, we need to know the radius, because both of our equations for circumference and area include radius. So that's what we have. We need that first of all. So we need to read that from this equation. I remember at the very beginning, all of you were here last week, what we were doing last week with equations of circles. It's not, oh, I see 64 pi. Good, yeah, so the radius is going to be the square root of the number over here. And we can actually leave it in the root for the area, but I'm going to just calculate it and say that therefore it's 8 centimeters. Perfect. You're good. Yeah, perfect. Which you're all right. Therefore the area is, because it's pi r squared, we just square it back up and get back the 64. So 64 pi. And therefore the circumference, which was 2 pi r, is also just going to be 16 pi. Yeah, good. It seems like you're all following along. You're all very happy with this stuff. So we'll move on. We'll have a look at how this is applied in some of the harder exam questions. So first of all, let's look through this one here. And I will just organize myself. So the diagram shows a flower bed in the shape of a circle. The flower bed has a diameter of 2.4 centimeters. Sue is going to put a plastic strip around the edge of the flower bed. The plastic strip is sold in 2-meter rolls. How many rolls of plastic strip does Sue need to buy? You must show all your working. Okay, so type in chat anyone who knows where you'd start with this. We need to first figure out what it wants us to calculate for this question. So we've already, because this whole video is on areas and circumferences, you probably already know it's one or the other. But yeah, that's the first step really, is figuring out what do we need to know to answer this question. Okay, good. Yeah, you've pulled out the radius, which is always a good thing to pull out over here. So the radius is going to be 2.4 over 2, which is 1.2. Find out the circumference. Yeah, you're completely right, Reham. So it tells us that she's going to put the strip around the edge of the flower bed. So she's just going to wrap this around the length out here. So we don't need to find the area because she's not filling the inside in. So yeah, first of all, let's find the circumference. Good, yeah, you're doing great. Okay, good. So the circumference, our equation for that was 2 pi r. We could also directly use the diameter for this equation and say this is the pi times the diameter, whichever one. So that's going to be 2.4 times pi, which is, and correct me if I'm wrong, this is I really quickly put this in my calculator earlier, but that should be 7.54. Good, yeah, you're getting the same as me, which reassures me. Good, so there's the circumference. And do we find the circumference because it tells us about the edge? Yeah, exactly. If you think about what we're doing in here when she's wrapping it around the edge, because it's only going around the length, we only want to find the length of the outside, or the perimeter of the shape is really what the circumference is. We just give it a fancy name because it's for a circle. Whereas if she was filling the inside of the shape in with the rolls, for example, if we were tiling a floor is often a common question. In that case, we need to know the area. Good. So that's the circumference. And I did see someone already tell us that we need to divide it by 2. And yeah, Liba, yeah, you're completely right. So we're told that the plastic strip is sold in 2-meter rolls. So for the rolls, for every 7.54 meters, we use up 1 roll. Oh, sorry, 2 meters of that is 1 roll. So if we divide that, we will end up with 3.77. And for these questions where you're like buying oh sorry, I always forget that moves your screen too, sorry. Yeah, whenever we're buying like packets of things in these questions, we can never buy a decimal point of a package. So you actually always round up. For this one, it's quite obvious because you'd always round 3.77 up anyway. But even if it was 3.1, at this point you'd round up because you would need the extra roll for that 0.1. So therefore, we need 4 rolls. Is 2 pi r the same as pi d? Yeah, it is. All I'm really doing going from like here to here is saying my diameter is 2 times r, and so therefore these two things multiplied can just be written as d. How many marks is this question? I can tell you. So 1 second, where did I put it? I can't remember. You can double check this. I have put the exam down here to find exactly how many marks, but I think it's probably like 3 marks would be my guess. Yeah, you can go look up this exam paper and double check that. Okay, so we will carry on. Oh yeah, Misam, yeah, Liva's kind of answered this. So why do you divide by 2? Because each plastic strip is sold in 2-meter rolls. And that's why we need to divide by 2. Because every 2 meters we've used up a roll. So therefore we need to divide it to find out how many rolls we actually need. Okay, so we'll carry on though. So we'll do this question next. The diagram shows a circular pond with a path around it. The pond has a radius of 5 centimeters. Oh, sorry, not 5 centimeters, 5 meters even. That would be a very short path. And the path has a width of 1 meter. Work out the area of the path. Give your answer to 3 significant figures. And these again are really common exam style questions, like not necessarily about ponds and pathways, but where you have areas and a shaded bit that you need to figure out. Not just for circles, but like for any shape. And for these ones, what you really want to think is try and find a combination of the unshaded and shaded one that you can work out, and then figure out what you're cutting away or what you're taking away from the whole shape to get the shaded bit on its own. So for example here, what I would notice, and again, if anyone like wants to sort of say what you would do to do this, please do in the chat. But what I would notice is that we have, yeah, I'm really bad at drawing, so I'm just going to try and dash around the edge. We have a big circle on the outside that includes both shaded and unshaded. And then within that, we have another circle. And if I was to like draw these on a bit of paper and take some scissors, to get that shaded region, I would have to cut out the inner circle. So therefore, if I'm cutting out from a bit of paper, that means I'm taking it away at the end. So I need to find both of these and then take away the inner circle to just be left with the shaded bit. So we can have one for the big circle and one for the small. Just a question related to this. What does the equals dash mean in exam again? I can't see it on here, sorry. If you explain that again, like just because I can't see the symbol, and that's probably just me being a bit blind. But yeah, let me, if anyone else knows what Liber means, like maybe type that in there too. Okay, so, oh wait, not equal, so you mean this. I'll carry on doing this, but if you do mean this, just put this on here. So, okay, so for the big circle, we're again going to use area equals pi r squared. So that's going to be pi times, and for the big circle, that's 5 plus 1, because that's included in our radius from here up until here. So this squared, which will be 6 squared, which is 36, and then pi. Yeah, I see a lot of people have helped answer that. It does mean just not equal to. So if you have that in an equation, it would mean show that this equation cannot be true. Yeah, so this is going to be the area of the big circle. And then the small circle, the area is going to be with a radius 5 this time. So that's going to be pi times 5 squared, which is going to be 25 pi. For these questions, I like to keep pi in there until the very, very end. So I only have to round it that one time, and it just keeps my answer more accurate. So I'm going to leave pi until the very, very end. Also, sometimes if I end up dividing numbers, I can get a bit lucky and it can cancel out. So the shaded area is going to be the difference between these. So it's going to be the big minus the small. So it'll be 36 pi minus 25 pi. And that's going to give me 11 pi. But they wanted it to 3 significant figures, which means I do have to actually round this, which will be, and I can see lots of people have the answer here, say 34.6 meters squared. So yeah, so that's how, not just for circle questions, how you want to approach these ones. And I think we have time to do the last one here as well, which is very similar. So it's very similar to the last one. Again, we have shaded areas within circles. It's just this time the shaded region is within the circle. Oh, you needed to read the question properly. You can always watch this back, Rihan, and go back and read that. It was to find the shaded area. So, okay, so for this one, the diagram shows a logo made from 3 circles. So we've got these 3 here, and the bit in the middle is shaded. Each circle has a center O, and Daisy says it's because it didn't round to 3 significant, oh wait, let's go back, check that then. So 3 significant figures over here. So that's how you know. Okay. I hope that helps. So here, each circle has center O. Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show all of your working. So this is now figuring out ratios, proportions and fractions of things. So whenever we have something like this, that means the bit we're interested in over the total. So for this, the bit we're interested in is the shaded bit. So the shaded area divided by the total area. So really what we need to do is first find the shaded bit, and then also just find the area of the big circle around the outside. So what we will do is, so for the shaded area, just is, if I go back and compare it, this and this, if you're just focusing on the middle, are basically the same. So again, we just need to find the medium circle, I guess, like this. So this circle around here, and then take away the bit inside it. So for the medium circle, that's going to have a radius of 4 plus 3, so 7. So we can say the medium, kind of go a bit Goldilocks here and have big, small, medium. So the area of the medium circle is going to be pi times 4 plus 3, so 7 squared. which is going to be 49 pi. And again, I'm going to keep pi in there. So then I need to find the small circle, and the area of that is going to be pi times 4 squared, because that's the small bit in the middle that we're going to cut out. So just like the question before. And that's going to be 16 pi. So therefore the shaded area is just going to be the difference between these. So it'll be 49 pi minus 16 pi, which will give you 33 pi. And then finally the big total circle, so the whole circle, so the big one, the area of that is going to be 4 plus 3 plus 3 for the radius. So it's going to be pi times, so 4 plus 3 plus 3 is 10. Which is 100 pi. Surely Daisy is correct. So she's almost correct. So if we put this into our fraction here, so the shaded area would be 33 pi. The total area was the big circle, which was 100 pi. Pi's will cancel, which is another advantage of keeping the pi's in there. Sorry, so this is going to simplify to 33 over 100. And this is not exactly a third. So the key is that she doesn't say roughly a third, she says exactly. If she said approximately, then yeah, there's a big argument for her being correct. But technically a third would be 33.3 recurring, which this is not. So for this one, actually, the answer would be no, she is incorrect. Was there a reason you first calculated the medium circle? You could do it in any order you want. Intuitively for me, I wanted to do the medium circle because, like, to my eye, I'm saying that the shaded area is made up from that medium circle and just cutting out the hole in the middle, cutting out this. So I wanted to find the shaded area first, and just intuitively that was by doing the medium circle first. But there's no right or wrong way. As long as you get to the correct answer at the end, it doesn't matter what order you calculate the circles. Yeah, I hope that was helpful. These always seem to go so quickly, but we are finished. We've already got to 5:30. If you found this useful, or if you think there's anything we can improve on, do go on the feedback link. Also check out the chemistry and computer science videos too. They're really useful. And yeah, thank you for all being here. I am going to head off and hopefully see you next week. Next week we are doing sectors and arcs, so we're carrying on with the circle theme next week, and the week after we'll be doing some vectors. I think there's a bit of a delay, but yeah, I hope that answered your question. So sectors and arcs next week. No worries, thank you for being here, Bella, and everyone as well. As always, it's really nice to see that people are returning, so I hope that means that you're finding them helpful. And yeah, I am going to try and head off. I always see if I can figure out that there it is.